Okay, random variables and expected value. All right, expected value is the main theme, and it goes something like this. If you've got some money in your pocket, do you get that? Like in my wallet right now, I have a bunch of bills. Most people do that are adults. They have a little bit of cash anyway they carry around. Okay, if I reach in there and let's say that I can't see what it is, so either I'm blind or it's in the dark, and I grab a bill, do you get that there's a chance it might be a 20, it might be a 10, it might be a 1? Okay, what would you pay for the opportunity to take the bill that comes out of my wallet? Would you pay $1? Would anybody pay more than $1? Now you guys are suspicious that I'm trying to cheat you, so I mean if it was truly random. If it's truly random, would you pay more than $1?
$10, yeah.
Because, what are you thinking? You're saying that you'll pay $10 because?
It's a good, like,
I assume your assumption is you might get more than 10.
Yeah, the most you can lose is 9 and the most you can gain is 10.
Okay, so you're pretty likely I might have a 20 in my hand, right? And see, you would have made $10. All right.
they would have made 19. Yeah.
What? Oh, if they'd have paid 1, but I wouldn't have played the game for 1. Know what I mean? See, I wouldn't play the game for 1, but I would maybe play the game for $10, because I do have some 1s in here, and every now and then, you know, I'd be making out pretty good. And then, okay, so the point is that expected value is what do you kind of expect it to be worth? All right. So here's a scenario. In your wallet, you have 10 $1 bills, 4 $5, and 1 $20. You reach into your wallet and remove a bill without looking. What's the expected value of the bill you'll take out? Would you agree that it's more than $1? The way this is best thought of is what's it worth? The expected value is what's this worth? It's worth more than $1. Wouldn't you be kind of stupid to pay $20 to play this game? Yeah, because all you're going to do is get your money back if you get lucky. So somewhere between $1 and $20 is the fair value of this. All right, well, let's look at another one. Go to the spinner. You can't actually spin yours, but I can. So, how about this game? Would you pay $1 to play this game?
Yeah.
Definitely. Would you pay $12 to play this game? No. Do you agree that somewhere between $1 and $12 is a fair price? That's like perfectly fair. There's some price that's perfectly fair to play this game. As in, you wouldn't likely, on average, you wouldn't win very much or lose very much if you played it a whole bunch of times. Yes? Okay, what I want you to do actually is I want to get some exact, what you think the fair value of this is, and I'll tell you what the right answer is in a minute. I want your gut feeling, and I want you to put it on the free response app that we made. Remember the one that goes through Google? So it's a little, as long as you've already logged into Google to correct your homework, you're already in. So you just go to free response. It's that app that's on your desktop. All right, I want you to type in for me what you think this game's expected value would be. What is it worth to play? All right, so I am going to go to my Google Docs now, and I'm going to pull up my free response app. I'll be able to see all the answers as they come in here. All right, here they come. Somewhere around 10, I think. $8.75, $7.50, $6, $3, and some curry. Sonny. All right. So most of you guys are saying like around $7-ish is what it's worth to play. All right. So how do you figure it out exactly? Write this down. P with a star, A, then write then, add. Take a wild guess what P stands for, considering what unit we're in. probability, times what do you think A stands for in the context of this problem? Average is a good guess. Amount is correct. Amount. Probability times the amount, and then you add them all up. So tell me, what's the probability of landing in this little spot, the blue one right there? 1/4, so 0.25. Times the amount that I would get if I go there, 20. And then the probability of this one, 25%, times the amount I'd get, 10 bucks. And then this one, 0.25 times 0, that's a really easy one to do. And the last one's 0.25, ooh, I'm writing with red on red, which is really not good. 0.25 times 5. We need to multiply those all out and then add them all up. You need a calculator. I would pause. I'm going to pause for a second while you grab one. Grab your graphing calculator. Don't try to do this on the iPad. There's too many numbers. You're going to have to go look to the left and the right. Switch screens too often. It's crazy. And the other reason that we need you to just have your regular calculator is because you can't just get all used to the iPad for everything, because you can't use it on the MCA test, or you can't use it on the state, like ACT and the MCA, or excuse me, there's too many letters. ACT, SAT, and MCA tests all use graphing calculators. So if you don't have one right now, borrow one of mine. I have some up here. Rápido, por favor. He wasn't going for the pink one anyway.
I was.
All right. So multiply them out, add them up. I can do some of these in my head. Like, I'm pretty good at multiplying by 0. That's 0. 2.5 times 10, I just moved the decimal over. That's 250. $2.50 is what that's worth. And if I double that and it's worth 20, then it should be double worth 250, so it should be worth $5.
Yeah.
And that's not the final answer, though. So wait. So then this one, 5 times 250, this is worth $1.25, I think. Did anybody verify that for me? Okay, good. So then I take this plus this plus this plus this to get my total. 750, 875. So who was close in here? 875 on the nose? Okay. Now, 875 if you had a good gut feeling about taking an average, but in this case that worked really well because every section was equally likely, right? What if my wedge had looked like this? 100 bucks. 0. I like one of the kids last hour, I asked them to come up with an idea, and I like this one. He has 0 right around the 100, so that you have a good chance you're going to get nothing, and then if it like stays in the 100, you're going to win 100 bucks. It'd be pretty exciting. And then let's say, just divide this up and make it worth like 5 bucks and 10 bucks. That was again a kid last hour. I like that idea. So, would you pay 5 bucks to play this game?
Yeah.
Yep. Would you pay 20 bucks to play this game? Some people are saying yes. Okay. How about, would you play $8 to play this game? Okay. All right, so let's do this. Let's figure this one out. It's really not going to be that hard. We're going to have to make some assumptions here. Now, would you agree that that is half of the circle? All right, so there's 50% chance of all of that. And would you agree that this is more than half of that half? Okay, so that's got to be worth like not a 50% chance, but maybe a 30% chance of that. Okay, so let's go with 0.3 times chance of that, 0.3 times chance of this, because those are meant to be the same size. Okay, so 0.3 and 0.3 makes 0.6. We got 0.4 left. Of our 0.4 we have left, could this be like 0.2 for that section? And well, no, that's too big. 0.15 for this, 0.15 for that, and then 0.1 for this. This is 30. This is 30. That makes what's left here. This whole thing has to be worth 40. So 15 and 15 makes 30 plus 1 is 40. Good. All right. Would you please figure out the exact probability and therefore the expected value. Sorry, I just did the probabilities for you. Now you got to times it by the amounts, and then you'll figure out what this game is worth. This part's worth $3 by itself. This part here, 0.1 times 10 is worth $10. 0 is worth 0, and 0 is worth 0, of course. And this would be worth $1.50. 14 and a quarter. All right. It's hard to tell sometimes, but when you do the math on it, it makes it pretty clear. If it's 14, what was it? 14 and a calf? 14.50. Then, what do you think they'd actually charge at the carnival for this? 15 at least, maybe 16. 20 might be high enough that a lot of people would say, I don't think I'm going to play it. You know, they have to set it just right. The casinos don't want to make it so you lose a lot. They want you to make it so you lose just a little bit on average, because they don't want it to look like it's a really stupid thing. Because they don't want the culture to spread that, oh, going to the casino is stupid, you have no chance of winning. They want it to be close. But then they'll let you, encourage you to stay for a long time. Keep gambling, because on average they're making a little bit on every dollar you bet. You know why at a casino they have really ugly carpeting? To keep you from looking down. They want you to look up and see other games and things that you could be playing. Did you ever notice that there is no clock?
Yeah.
I don't know if you've ever been in a casino, but there's no clocks. You seriously can't tell what time it is. You have your own watch or your cell phone with you, but in the old days, people didn't have, ways to tell the time as easily. And just think about it. Why would you not put a clock up? Because you don't want people to realize you've been in the casino for like 7 hours. Oh my gosh. Another thing they do is they bring you free, like free pop, and because they want you to stay hydrated, because they want you to stay there for a long time.
Don't they reduce the oxygen level in the room so that you don't think properly?
They actually add.
I heard that.
They add oxygen.
I don't know. Maybe they. It seems like it would be pretty dangerous to be messing people's oxygen levels.
Just a little bit. I don't know if it hurts.
I can see you as a casino executive. It wasn't enough to hurt them, just to make them stupid. That's fair. All right, so casinos make a tremendous amount of money. Did you know that the casino at that's down south of the city's Mystic Lake? Yes, Mystic Lake. The average owner, the owners are all the Indians that are in the tribe. Okay, the average owner makes well over $500,000 per year. So if you're a member of the tribe, you're bringing in over $500,000 a year of profits, and it's way more than that. I'm underestimating because I don't want to tick anybody off. It might be, I know it's higher than that, but I don't know how much higher. Saw a newspaper article about it. It was insane. So then what happens? A lot of people say, hey, I'm an Indian too. I got a little bit of, like, tiny bit of me is, so they made a rule saying how much Indian you have to be to qualify, because everybody wants to sign up like, hey, I know somewhere in my back history I got like 1/10 Indian in me. So anyway, so they have rules on exactly how much, and you have to prove it, and of course, because a lot of scammers out there would love to just say, hey, and even Indians from other bands, it'd be pretty easy to say, don't I look like I'm an Indian? Well, it's because you're from the band that's up north. You're not from our band, so they have to prove it. But one of the things too is if you have kids, the kids all of a sudden are members of the band, right? And so the kids automatically, there's kids who are born who are grandfathered in, that they're going to be getting tremendous amounts of money, and they set it aside for them until they're old enough to so that means the money's just growing and growing and growing. So anyway, casinos are set based on probabilities. So it's good for you to understand them so that you don't make big mistakes based on that. All right. The official expected value definition is the sum of the probability of each possible outcome. Well, I just said that the P, and then the sum means add them all up. Multiplied by, that's the times I was talking about, the outcome's value. I really like the P times A, then add them all up. And one of the things that you need to understand is if you do it over and over, that's what's going to happen. Because it's not like if we play this game, you're instantly going to win $8.75. In fact, the expected value, $8.75, you can't even possibly win that. Do you get what I'm saying? You're either going to win, you're going to pay a buck, or whatever you're going to pay, whatever they charge, and you're going to either get 10 bucks, 20 bucks, 5 bucks, or 0. You're not going to get $8.75. It's an average. It's just like if we take the average number of kids in Minnetonka per family, it's like 2.2. So that means like a 2 point, there's a 0.2 of a kid running around somewhere in everybody's house? No. All right. I think you get the point. It's an average. All right. This one. Look at this. It's got probability lined up. Oh man, my alignment's really off. I want to pause for a second to fix that and start the recording again. All right, so this one's all set up nicely, so my probabilities are right next to my amounts. This is credits in college. There's not many kids who take 14 credits. There's a lot of kids take 15 credits or 16 credits. And there's a kind of a medium probability. Some kids will take 17 credits, all right, at this school. Well, you just take the probabilities times the amounts. You get an amount through this, and this, and what would I do with all those numbers? Add them all up. You can see what the probability is that you're going to take a certain number of credits. All right, good enough on that one. That's just a lot of multiplying for not much learning. Okay, this one. This is another kind we get into a fair amount. It's probabilities on a test. If you're taking a 100-question test, number 1, number 2, number 3, number 4, and it's multiple choice, and you just decide to guess. Total guess. Not like narrowing it down or anything, just random guessing. Do you get that if there's 5 choices, A, B, C, D, E, that you have a 1 in 5 chance and therefore a 20% chance of winning, guessing right on each question? How many points do you get if you get a question right? 1. So it's this times 1, plus this times 1, plus this times 1. Now generally you want to do P times A and then add them all up, but do you really want to add up the exact same thing 100 times? No, you probably want to multiply at that point, right? And so you take whatever this is, which 0.2 times 1 is 0.2, and you times it by 100. All right. So what is wrong with that picture then? Times by 100, move it over 2 spots. Oh, yeah, moving it over 2 spots is not 200. Moving it over 2 spots is 20 out of 100 is your likely score. Does that make sense to you? 20% chance? I mean, all right. Good point. On a test in Minnetonka, as long as you have shown effort on every question, which would mean if you're just bubbling in every other, question, that they probably wouldn't give this to you. But as long as you've tried on the test, we try not to give anybody lower than 50%. So you're right. And the reason is because if you get a grade that's that low, like a 20 out of 100, you are toast for the whole rest of the semester. You can't get out of the hole. It's like no matter what, if you try your hardest and you're like the ideal student, you can't get out of the hole. So anyway, that's why we have that 50% limit. You're right. All right, cards. That's another really common scenario. So you gotta, even if you're not good at cards, you have to at least understand how the deck of cards works. A deck of cards contains 52 cards, 4 of which are aces. All right, so there's a 4 in 52 chance of getting an ace, right? Ace. Do you really want to list every other kind of card? In this game, you only win on aces. Does it make sense to list every other kind of card? No. No. So you'd say either ace or not an ace. And you'd want the probability times the amount, and then we will take the probability and the amount and multiply them, and same for this, and then we add them all up at the end. All right, I'd like you to write this on your paper. And I'd like you to fill in the little circles with what is the probability of getting an ace? Well, there's 4 of them in a deck of 52. So you can figure out the decimal for that yourself with the calculator. times the amount you get if you get an ace, which you can read in the problem there. All right. I like to figure in the losing the dollar thing is just meaning you're not going to win anything. The amount you win is 0 on this one. The amount you win is 15 on this one. Okay, probability. What was 14 out of 52? 0.25? Oh, sorry, 4 out of 52. Sorry, what is 4 out of 52? 0.77, thank you. And then that must be, there's like a 93% or 0.923 chance of not. And then the nice part about multiplying by 0 is that it's just 0. And this one, somebody needs to help me with. What is 0.77 times 15? Good enough, thank you. $1.15 plus 0 is $1.15. Now, if you compare this, $1.15. Just wait. No, I'm pretty sure it's $1.15. Last hour was $1.15, so unless it's changed from last hour. If you paid $1.15 to play this game, it would be exactly fair, right? What do you pay to play this game? $1. So now, to get your expected value, you have to subtract off how much you had to pay to play. You get what I'm saying? So now, if I had to pay $1 to play, I subtract $1, and now I have an average win of 15 cents. That's not very big, but a casino owner would say, yeah, and if you get 1,000 people to make that bet every hour, think about this. If you're making 15 cents every time, move this over 3 decimal places, that'd be 150 an hour that machine could be bringing in. See what I'm saying? So even a small win, if you could multiply it by a big number, can be impressive. In other words, if you could make $1 every time you sold something, it may seem like I only made $1. But then what if you could figure out a way to have that happen in 100 cities in the United States every hour? All of a sudden, you're making $1 times 100 is $100 an hour. And if you could keep that going like all day long, man, you could all of a sudden make tons of money on it. So if you can figure out a way to consistently make $1 that's replicable, as in you can like make it happen in other places, don't sneeze at the, oh, it's only 15 cents. If it's in your favor, then if you can replicate it, that's a good deal. So this game, bottom line is, it was making you money. See, you got 15 cents at the end. So you should actually play this game. Does that mean you'll win for sure? No. There's still a chance that you get unlucky. But on average, you would win 15 cents every time you played it. So for practical purposes, if you're only going to win 15 cents every time, unless you can win it pretty fast, like you can play the game, play it again, play it again, play it again, it's not going to be really worth it. If it takes you like 10 minutes to win the 15 cents, it's like, okay, not worth it. All right, moving on. Another deck of cards problem. This time it's about hearts. I'd like you to just read it and try to figure out if you can get the right answer for this. Just you, not me. Use your calculator. P times A, then add them all up. Don't worry about the comparing it with the previous question. That's pretty obvious. Just figure out for me what is the fair price for this game. I'll get you started. You're either going to get a heart or you're not going to get a heart. It's like a tree diagram, except it's very simple. Okay, probability times the amount, and then add them all up. Probability, 13 out of 52. That's 25%. 25% chance of a heart? And if so, you're going to win $5. Otherwise, which is 75% chance. If you said you lose a buck, you kind of missed the point what I showed you before. If you said -1, just you're not going to win anything. We'll take in the dollar at the end. All right, so this is $1.25. This is nothing. Put them together, $1.25. Now, have I taken into account my $1 that I had to pay anywhere yet? Now I take it into account, and I take away a buck, and I have 25 cents. I will make, because that's a positive number, I will make 25 cents every time I play the game. You see how that's better than the 15-cent game? Still not a tremendous moneymaker, but hey, it's actually, compared to the buck you're paying, you have a 25% payback on your buck. 25% is a pretty good return on your money. See, at a casino, a lot of times, they'll let you bet not just a buck, they'll let you bet $100 or $1,000 all at once. So then, if you were to have a 25% payback and you're betting $100, that means on average you're going to win $25 back. That's a great deal. Okay, so whoever set up this game would go broke. All right. I want to skip to one last one. I want you to find example 7, because this is on the test a fair amount. We usually put it on quizzes and tests, and it has to do with replacement plans that you can buy at the store. We can figure out what their fair value is. Like, for instance, when you buy an iPad, like you have in front of you there, did you know you can buy AppleCare for it? And the AppleCare is usually like $70 or so. And the question is it worth spending the $70 or not? You can do a simple mathematical equation and figure out what's the fair price of the warranty. And if they're charging you more than that, then it's not a good deal. Now, some people will buy them anyway if it's worth peace of mind. They don't have to worry about dropping their iPhone or their iPad. Or I did that on my iPhone, because now they have a deal where it was $100 for the warranty, but it also covered dropping. So I could throw this against the wall right now and it'd be covered. Okay? Don't want to, because they did something smart. They said you can only use it twice. Okay, and that each time you use it, you have to pay a $50 deductible, meaning I have to pay the first $50, and then they give me a new phone. So I would lose $50 if I threw this against the wall, but it's a lot better than if you have to replace this without a contract, $600. So to me, that was worth it for the peace of mind too, because every now and then I have it in my hand and I'm like, whoa, almost drop it, and I'm like, crap, if I'd have dropped it on the floor, I would be gone, and I'd have to pay $600. Well, now it's like, well, I don't have to pay $50. It's not that big of a deal. Okay, so sometimes I'm trying to make the point that it's not just about the math. You got to take into account, is it worth it to you? Is it worth spending a little bit of money to have the peace of mind? All right, so this kind of problem, there's two things on your tree. It either works and it never breaks, or it breaks. All right, now, if my camera costs $300 and the replacement plan is $75, and it tells me there's only a 2% chance it's going to break, then there's a 98% chance it's going to work. You get that? And there's a 2% chance it's going to break. P times amount I get if this happens. If it breaks, guess what? I get nothing. I'm putting a 0 there. If it works, I do get something. I will get my $300 back. They'll give me cash. And in the real world, that's not what usually happens. Is that happening backwards? Yeah. Sorry about that. If it works, I get nothing. Sorry. If it breaks, I get $300. In the real world, they actually just, if it breaks, they repair it, which is a smart deal for them, because they don't want to have to give you your money back. They just want to fix it, because they can fix it fairly cheap. All right. So, if I do times 0, that makes 0. And if I do 0.02 times 30, it's, I think, is it $6? Well, after P times A, what do you always do? Then add them up. So if I do P times A and add them up, I get $6. I'm pretty sure it's 6. Okay, it's all right. It's all right. So $6. That's what that warranty is worth.
What did we pay for it? 75.
Did we make money? No.
We take our $6 now, we subtract off the 75, and we'll be able to figure out that we should net lose $69 by buying that warranty.
Not very smart. Now, is it possible that the percent breakage could change all of this? Yeah. If it turns out that iPad 2s start dying after a year and a half, you know what I mean? Like something in them is programmed wrong or whatever, all of a sudden they all start dying after a year and a half, then you wish you would have
Bought the warranty, right?
this is about a camera, but you get the idea. If all of a sudden a high percentage of them break, then this .02
Would be like, let's say it was like 80% chance it breaks, then holy cow, that'd be a great deal. You'd make a lot of money on average having bought the warranty. All right. If you heard this once, I probably heard it 10 times. P times A, then add. This is for expected value.
The next thing is, when you get an expected value, you will never actually expect to get the expected value. It's an average. Do you think you're going to have 2.2 kids when you grow up? No, because you can't get .2. But the point is, on average,
That's the average family size. It does change over the years too. Do you know if it's growing or shrinking? It's shrinking.
the average family is shrinking. It's getting a little bit smaller. It really depends on the area, though.
There is a correlation with income too.
But anyway, so in other words, in areas where people can afford to have more kids, sometimes there's more kids. And some of the other places where everybody is really, but there's not that there can be exceptions to that too. So family can be really poor and just have tons of kids. So,
All right. P times A, then add.
also, if you're going to remember one other thing, it's that this whole thing is an average.
It's an average.
What you'd expect. It's not the exact amount you're going to have actually happen. It's an average over time. All right, so let's actually do a problem together. It's a little confusing today because there's two worksheets. You want the one that is called
12.4 worksheet A. And there's another one that says that same thing, except it says that the assignment says finding expected value. Don't do the one that says finding. Throw that one out. Or just don't open it. Do the one that says expected value 12.4A. And if you do, the first problem that comes up will look like this, and it's got all these lines through it. You know what that means? Don't do it. We're skipping that problem because it was too confusing. All right, so we're going to go to this one. And it... Oopie, I hit the wrong button. Hold on. There. All right. I know there's two things called 12.48. Now, one you want is the one that does not say finding in front of it. You want the one that says just expected value. Okay. A survey was conducted by the Public Housing Authority amongst 1,000 families to determine the distribution of families by size. They found two families. No, wait. They found 350 out of 1,000, which means 0.35 is your probability. This times this will give me 0.7. This times this will give me 0.6. 0.245 times 4, etc. And then what do you think I do with all of these numbers? Add them all up. And I will be able to figure out what my total is, and that'll tell me if I grabbed a random family, how many kids would they have. All right, one more thing. Some kids just go, oh, well, so you just put decimals in front of all these, huh? So 0.66? No, because it's out of 1,000. 66 out of 1,000 would be 0.066. See? I got to move the decimal over 3 spots, so I need a 0.066. 0.010. And on this one, 0. All right, once you got all of those and you add them all up, then you'll know what the expected value of the family is, as in how many kids you'd expect the family to have. Expected value. I think you can handle multiplying and adding, so I'm going to move on. Sorry, I'm having Adobe Acrobat issues. It won't let me move this thing over. There we go. Okay. What that is? It's interference from the phone, that's correct. You get the phone away from the receiver thingy, and then it stops. Or you shut off the phone if it's really obnoxious. All right, at this one, there's 100 mathematicians and 72 are men. Right away, I'm thinking probability. What is the percent chance of picking a man? Yep, probability, 0.72. Amount, if you get a man. Well, the amount in this case is the height. The amount of height they have, 1.79. That times that, and then you take women. Same idea, 28% chance of women. Amount of height they have on average. When I do P times A and add it all up, I get my expected value. And that would mean about how tall should the average mathematician that's at this conference be. Remember, it's again, the probability, your expected value is an average when you're all done. So we're going to see, I bet you it's somewhere between 1.62 and 1.79. It's going to have to be. Because the men on average are 1.79, the women on average are 1.62. It's probably going to be somewhere in the middle. It's probably a little closer to the men's side, though, because there's more men. So I'm going to guess it's probably going to come out to like 1.71 or something like that, or 1.73. All right. You have the rest of the time to work. If